All right, let's talk about something that is absolutely critical, but you probably never think about. We're going deep offshore to look at the one system that stands between a massive oil rig and complete catastrophe. And believe me, this isn't just about ticking off some safety checklists. We're talking about the last line of defense, where lives and literally billions of dollars are hanging in the balance. So let's just stop and think for a second. Picture it. You're on this giant steel island, hundreds of miles from the nearest shore, surrounded by a whole lot of stuff that's, well, highly flammable. What do you think is the number one absolute biggest threat to every single person on that rig? You got it. It's fire. But a fire out here, it's a completely different beast. A fire on land is bad enough, right? But on an offshore rig, you are utterly isolated. The nearest fire department is hours, maybe days away. There's just nowhere to go. So to really get why we're talking about something as specific as fire pumps, you've got to really visualize this. A rig on fire isn't just some technical glitch. No, it's the absolute worst case scenario, a situation where every single second counts. And that is where the hero of our story enters the picture. In this incredibly high-risk, isolated world, the fire pump system is that last line of defense. It's the guardian, the thing that stands between control and chaos. And it has to be perfect, not just most of the time, every single time. So let's meet the key players on this team. Okay, first up, you've got the main powerhouse, the primary fire pump. Think of this thing as the star quarterback of the team. It's a huge centrifugal pump, which is just a fancy way of saying it has a rapidly spinning wheel, an impeller, that literally flings seawater outwards with incredible force. We're talking up to 5,000 gallons every single minute. When that alarm goes off, this is the beast that has to wake up and perform, no questions asked. But hang on, what happens if the fire itself knocks out the rig's main electrical power? That's a huge problem, right? Well, that's where the insurance policy kicks in, the backup diesel engine. This thing is a tough, rugged engine that sits there completely separate from the rig's main power grid. Its only job is to make sure that even if the lights go out, even in a total blackout, those pumps keep running. It is the ultimate failsafe. So you've got all this muscle, but what tells it when to act? That's the job of the controller. This is the brain of the whole operation. It's constantly, 24/7, monitoring the water pressure in all the fire suppression pipes. The second a sprinkler head pops, that pressure plummets and the controller senses it instantly, firing up the pumps in less than 30 seconds. No one needs to flip a switch. It's all automatic, all about pure, blinding speed. And last but not least, you have the silent partner, the jockey pump. Now this is just a little guy. Its job is to handle the tiny, everyday pressure drops you might get from a minor leak somewhere in the system. It keeps everything topped up and pressurized so you don't have to kick that massive main pump into action for no good reason. It keeps the star athlete on the bench, rested and ready for the big game. Okay, so we've got this incredible, powerful system, right? The pump, the engine, the controller, the whole team. But this team doesn't just get to make up its own plays. Oh no. It is governed by a super strict, super complex, and totally unforgiving rulebook that dictates its every move. And it's not just one set of rules either. You've got the National Fire Protection Association, the NFPA. They set the really detailed technical standards for the gear itself. Then you have maritime authorities like the U.S. Coast Guard, and they add their own layer of rules for being out at sea. And then on top of all that, you have the insurance companies, the people actually underwriting the multi-billion-dollar rig. They have their own list of demands. It's this complicated, multi-layered web of compliance, and you have to keep every single one of them happy. And the financial stakes for following these rules, they are massive. Take a look at this number. We're talking about a 25 to 40% hike in insurance premiums for a rig that has a shoddy maintenance record. That's not a small number. That can be millions and millions of dollars every year. And in some cases, a bad record can get you denied coverage altogether. So yeah, maintenance isn't just a nice to have, it is very, very serious business. So to stay compliant and, way more importantly, to stay safe, these systems go through a relentless, constant gauntlet of tests. This is not a set it and forget it kind of deal. You have to think of it more like a training regimen for a world-class athlete. It's all designed to keep that guardian, that pump system, in absolute peak fighting condition. And this testing really breaks down into two main types. You've got the weekly checkup. It's pretty straightforward, a 30-minute run, no water actually flowing, just to make sure it kicks on automatically and runs smoothly, no weird vibrations or anything. But then, once a year, it's time for the stress test. And this is the real deal. It's a full-on, intense evaluation where they push the pump to its absolute limits, 100% of its rated capacity, and then they crank it up to 150%. They're trying to prove it can deliver when everything is on the line. But here's the thing. Even with all this constant testing, stuff can still go wrong. So now we have to talk about the villains of the story. The common, sneaky, and incredibly dangerous failures that can take our hero system down right when you need it the most. Listen to that phrase, that distinctive grinding noise. That's what engineers hear when one of the pump's worst enemies shows up, cavitation. Basically, this happens when the pump is trying to move more water than it can pull in. It's essentially starving. This creates tiny bubbles of water vapor inside the pump that then violently collapse. And these collapses create tiny, powerful shockwaves. It sounds like grinding metal because that's what's happening. It is literally eating away at the metal components from the inside out. Brutal. All right, the next villain isn't a mechanical failure, it's the environment itself. Just think about that salty, humid ocean air. It is relentless. It gets into everything. And it especially loves to attack the system's electronic brain, the controller. It causes corrosion on all the little terminals and connections, which can lead to short circuits, and that can leave your entire life-saving system completely dead in the water. And what about our insurance policy, that backup diesel engine? Well, its biggest enemy is simply being forgotten. I mean, think about it. It just sits there, waiting. And while it waits, water can condense in the fuel tank, contaminating the diesel. The fuel itself can get old and break down into gums and sludge. Tiny leaks can form in the air start system. And get this, marine life, like barnacles, can actually grow inside the cooling system pipes and clog them up completely. These are all those little quiet failures that suddenly turn into very, very loud emergencies. And all of this really brings us to the main point, doesn't it? When you add it all up, the complex machinery, the unforgiving rulebook, that constant gauntlet of tests, and the endless fight against corrosion and neglect, it all points to one central idea. The massive, painstaking effort of all this testing and maintenance, well, that's just the price of admission. It is the non-negotiable price you pay for vigilance and for safety. So, after digging into all these technical details, it's a fair question to ask, right? What's the real bottom line? Why does this one system, this one piece of hardware, demand so much constant attention and money and effort? Here's why it all matters so much. At the end of the day, it's not really about the pump. It's about protecting the lives of the men and women on that rig, who are totally on their own out there. It's about securing a piece of infrastructure that's worth billions of dollars. And maybe most importantly, it's about preventing a fire from spiraling into a truly catastrophic oil spill, an environmental nightmare with consequences that we could be dealing with for decades. So the next time you see a picture of one of these massive offshore platforms, maybe give a thought to the unseen guardians working deep inside. The fire pumps and the crews who spend their days meticulously maintaining them are doing one of the most critical jobs in the world. A job you will probably never see, because if they do their job perfectly, you will never, ever have to see that system in action. And really, that's the whole point.